So that's our first task. So that can't be that hard. We're going to display our name 10 times on the screen. So we'll start by doing a put Mr. Van Rooyen in quotes, and after that I'll just copy it and I'll paste it 10 times on my editor here. 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. Just need to run it, and you can see it comes up 10 times. And there we go. Excellent. We're done. So the second task is to do it 20 times. Well, that's not going to take me too long. I'm just going to copy these 10, and then I'll just go down here and I'll paste it, and voila, see, I'm at 20 lines of code, so I should be good. Run it. Sure, there's 20 there, and all's good. Excellent, we're done. Okay, so this task 100 times we have to put that out. A little bit irritating, but no problem. I got 20 already, so I'm just going to copy these 20, move down to the bottom of my code, and I'm going to paste them in. So I've got 20 already, so that's 40, 60, 80, and 100. So if I look at my lines of code, I'm not so bad, though I'd like that to be 100, but I'm not quite on the bottom. Anyways, let's run it. And I'm not going to count all those, but I guess it's near 100. Anyways, I guess we're done. Wait, what? 1,000 times? Oh, come on, that's enough. I'm not going to do it this way. There's got to be a better way. So we all knew there was a better way, in that we didn't want to repeat 1,000 lines of code, the same code over and over again, and just copy and paste. It's hard, as you've seen, it's hard to keep track of. But normally in a programming language, instructions are executed sequentially from start to finish, and each instruction is executed once and once only. But as we've seen, it's often desirable to repeat a section of code, and the repetition of a set of instructions is referred to as a repetition structure. We call this, of course, looping. There are 3 parts to every loop. Every single loop, no matter what language you're talking about, no matter what its form. They always have initialization, the body, and the exit. All 3 of those are required for a loop to be successful. So let's look at the very first part. It's called initialization, and every loop will have this. It's where we give values to any variables that are important in the loop. A lot of times we have one variable, what we call a counter variable, controlling the loop, and we give it an initialized value at the very start, once and once only. So for example, when counting from 1 to 100, we initialize the counting variable to be 1, so that it's ready to count up in the body. So the body is the second part of any loop, and it's going to contain any instructions that are going to be repeated. Whatever happens over and over and over again. It can be a single instruction or it can be multiple. Now in our code, it's really important that we actually indent the body of any loop to show that it's part of that inner loop, that body, so it's easy to pick out. That's the proper programming structure. And if you want Mr. Van Rooyen to help you, it better be indented. The exit is the last part of the loop that every loop needs to have. It's how the loop knows how it's done. Otherwise, it will just keep on going. And if it keeps on going, we get what's called an infinite loop or an endless loop. And while they're fun to make sometimes, they're really not what you want to do. The exit test, so the test that makes the loop stop, it can actually occur anywhere in that body. Typically, though, we put it at the end of the body. So this stage, you're probably wondering to yourself, alright, I get the idea. These loops have 3 different parts to it, initialization, body, and exit, but how do I actually do a loop in Turing? Well, we use, of course, the loop command. And we've got an example here of a loop command and how it shows the different 3 steps. So the first thing we have in this code here is this variable counter that we've identified. It's going to be an integer. We're going to use this, and a lot of our loops at first are going to have some sort of control variable that keeps track of how many times you go through the loop. And here we're going to use counter. And because we're going to try to count up from 1 up to 10, we're going to start the counter at 1. Now be careful, this program actually doesn't count from 1 to 10, but it does something very close to that. And see if you can pick up what it actually does as I go through. So there's our initialization, counter becomes 1, and then we start our loop. And you can see we use the command loop, which always is the start of a loop, of course, and it's a keyword. At the very end, we do an end loop. So when I do my programs, I usually start with the loop and then put an end loop right away so I don't forget it, and then inside I'm going to put my body. These 2 statements here are the main part of my body, and what this one is doing is adding 1 to our counter, and then we're going to display counter. If this never does happen, this adding 1 to the counter, then I can't get my loop to count up and actually exit. Speaking of exiting, here's my exit command. So we've got the initialization, the body, and the exit command. And this is saying exit when counter is equal to 10. So as soon as counter becomes 10, this thing's going to exit. If it never becomes 10, then we've got an endless loop happening. So let's just see how this would work. So we're going to start counter to be 1. We then go inside the loop, and it's working sequentially at this stage. And it says counter becomes counter plus 1. So counter was 1, it's now 2. And then we display counter out. And then we really ask ourselves this question. Exit when counter equals 10. So does counter equal 10? And the answer, of course, is no. So what it does is it kind of like a bounce. It bounces off the end loop and goes back up to the loop, and it's contained in here, and it keeps going. Counter becomes 3, displays 3. Is 3 equal to 10? No. Bounce and keep going. Counter becomes 4, put 4. Is 4 equal to 10? No. Bounce, and so on and so on and so on. So when does it stop? Well, let's pick it up when counter becomes 9 and it bounces. So counter then becomes 10. We display 10, and then we say, is 10 equal to 10? Is the counter equal to 10? And of course the answer is yes. So that means this is when we're going to exit, and so that would end the loop, and hence end the program that we have here. Another thing we need to be aware of when we talk about loops is a little bit more to do with the exit command. Now, as we know, as I've said, the exit command is what stops the loop from happening. And we can put all kinds of different conditions in there based off whatever we need in our loop. So as our example, we did an equal sign. An equal sign checks if something is true. Now remember, our assignment operator was not an equals, it was a colon equals, and that made the variable take on a new value. This is a check to see if something is true. So in our example, it was x equals 10. It was a check to see if x was equal to 10. We could have also used a greater than sign. So these would always be used in comparison between maybe 2 variables or a variable and a number. So for instance, maybe you might say exit when a is greater than b, or exit when a is less than b, or exit when a is greater than or equal to 10, exit when a is less than or equal to 10, those sort of things. So those are all our math inequality signs. The other one that you might not be familiar with is the idea of not equal to. So it's a not followed by an equal sign, and that's exactly what it's for. It's for if x does not equal a number. So do this as long as x is not equal to this. This is actually a good thing for a Boolean to be used in a loop, because if we have, for instance, a game state such as the hero's alive or something like that, we can do this loop as long as the hero remains alive. So as long as it's not equal to the death game state. Hopefully that makes some sense. But we can use any of these operators in an exit win. So that's a quick introduction to the loop command in Turing. We're going to ask you now that you work on these 7 questions at your computer, and you try each one and try to modify the example one that I gave you, the one that counted from 1 to 10. See if you can get it to count to 20, from 25 to 40, 50 to 100. Keep in mind what is the initialization, what should the body look like, and what should the exit command. The initialization and the exit should be most important for these. Questions 6 and 7, slightly different. We're counting down for number 6, so that might change a few things. We also do that in number 4 as well. And question number 5, we count by even numbers. So you have to think, okay, what do we mean by even numbers? How do they act together? For question number 7, drawing a square that has its bottom left corner in the bottom left corner of the screen, and it's going to move the right corner up higher and higher. Just give you a brief look at what that should look like, and we'll do it right here. So we'll just run the program, and you can see it building up at the bottom, and it's slowly getting bigger. So the bottom is stationary in the top right hand corner, so the bottom left is stationary, top right hand corner is slowly moving up. Now you can get it to move until it matches whatever is the smallest side, so probably that'd be your Y value, and when it gets to there it should stop. I don't really care what the colors are, but the box should grow up to that point there. It should not continue over to here. It should go up to the top of the Y value. Alright, so go ahead, go to your computers. You're going to work on loop exercise number 1. Please save each question as follows. So that's loop 1, question 1.t, loop 1, question 2.t, etc. The video is going to go on, and it's going to show solutions to each of those questions. I would recommend and actually insist that you pause this video at this point and come back to these questions when you're stuck, or come back to it just to check your answer. Okay, and if you finish all of loop exercise number 1, you're going on to loop exercise number 2. So good luck. So the task here is to write out all the numbers from 1 to 20. Now, this one, if you haven't run it yet, pretty good idea to do it. When we run it, it doesn't do 1 to 10, it actually does 2 to 10. So how can I correct it? Well, it might mean that we want to output counter first. So I'm just going to copy this line here and switch the order. And when I run it, now I've got 1 to 9. Oh, so that's very close. So how can I get it to be 10? Well, the problem is when it's 9, I display it. 9 becomes 10, so the counter becomes 10. And then what we do is we check and it stops. Well, it hasn't put out 10. So how about if we say when counter is greater than 10? Or you could say equals 11. Let's run it. And there we go. We got 1 to 10. So once we've got that fixed, it's not too bad to make it 20. To make it 20, it just means we've got to change that exit. Let's put it to 20 and run it. And there we are, 1 to 20. So question number 2 is to write the numbers from 25 to 40. So we're going to take up my last question, which was from 1 to 20. Now, 1 to 20. So here's initialization as 1. So in this question, I want it to be 25. So I put a 25 there. And when do I want it to end? When it's 40. So not 20, but 40. So I put 40 there, and I run it. And there we are, 25 to 40. Question number 3 is writing the numbers out from 50 to 100. Now you'll notice that each time I'm starting with a question that I already know and working with it. So if this one's 25 to 40, so then we want to go 50 to 100. So let's make that 25, 50, and then 100. This 40 becomes 100. And we'll just check. 25, 100. Hopefully it displayed for 25. I can find out just by changing how my counter gets put out. What happens if I did a comma, space, and then did a dot dot? So it's all in the same line. Let's run it, see what happens. There we go. 50 to 100. It shows up nice on my screen. I've got no scroll. So the fourth question is dealing with the numbers from 15 to 0, and it wants the output in a column, which means I'm going to get rid of my add to my last program. Make sure you're saving each one of these. I'm not, but you should be able to. Now it starts from 15 to 0, so that's a little bit different. This might have caused some problems. First of all, we're starting at 15, so my initialization is 15. I want to exit when this is 0. So if I put 0 there, right, that's for what we want. So watch what happens though when I run this. Well, it stopped at 15. How come? Well, in a few days we'll do what's called a variable trace, and it'll be easier to see. But we're going to start counter at 15. Counter is 15. We say counter becomes counter plus 1, so now it's 16. Counter is greater than 0, so it stops. It's 16. Now a couple of problems there you should have noticed. Counter was 15, it then became 16. That's not what we want to have happen. We want it to go down by 1. So instead of adding 1, I'm going to subtract 1. Now let's see what happens. I run it. Oh, still stops at 15. Well, let's go again. So it's 15, puts out 15, and now is 14. X1 counter is greater than 0. Well, of course 14 is greater than 0, so it's obviously going to stop. So what I can do is I can fix this to be less than 0. And now let's run it again. 15 down to 0. So on to the fifth question. The fifth question is asking us to do something a little different too. It's asking us to count from 100 to 120. Now you'll notice I've gone back 2 programs before, so I don't have the one that counts down anymore, but I'm going to count up by 2's here. It wants even numbers. Now the whole trick here is you don't have to worry about the starting. The starting is at 100. So that's an even number. And now we're going to count up 102, 104, 106, 108. What are we going up by? 2. So here we're adding 1. Well, we want to add 1 again. Or, to say it a little different, we can add 2. So we're going 100, 102, 104, 106, 108, all the way up to 120. So when we run it, there we go. All the even numbers from 100 to 120. So on to question number 6 now. Here we're looking at doing a nice little rocket countdown. So we're going to go 10, 9, 8, 7, all the way down to 1, and then blast off. And we might as well have a second delay in between. So we're going to start at 10 because that's initialization. We're going to stop, or if you remember, we're counting down. So like we did a couple of times before, we're going to go -1 instead of +1 or +2 or anything like that. And then we're going to go all the way down to 1. And we remember we have to switch this so that it counts down and then it stops. Because if we leave it as greater than 1, of course when it's 9, it stops. But we want to go 10, 9, 8, 7, all the way down. Now we want a delay of 1 second, so let's do a delay of 1 second. And we do it, it can go either spot. It can either go after the counter equals counter -1, what we call a decrement, or right after the put command. So let's run this and hope it works. Oh, one thing we forgot to do, was a blast off, and I'm going to put it at the end here, blast off, exclamation mark. And the other thing I needed to do is, I think I'm going to put the space back in, because it looks like in the question that it requires it to be all in one line. So let's try this one now. 10, 9, 8, 7, 6, 5, very exciting, 4, 3, 2, 1, blast off. Perfect. So the seventh one I'm going to do from scratch. It just doesn't follow the same as the other ones. So the first thing I'm going to do is a view.set. Now I can never remember the view.set, so I'm going to go to my help and pull up the view.set I like. I've already got it selected there. Oh, I've even got the one I wanted right there. I'm going to copy it and paste it because it's a wonderful thing, the help. And there it is. So it's got my graphics, and I'm going to go max on this one, and because I wanted it full screen. So what we're going to do here is we're going to introduce a variable that represents the x and really the y location of my top right corner. So, and that's what's going to count. It's going to move all the way along. So I'm going to define it var, what should we call it? Let's call it corner. And it's going to be an integer, and I'm going to initialize it to be 1 or 0. Let's go 1. Just so I start with a little wee square at least. The next thing I need to do is to, well, make a background, right? I need to do the background. Now each time I go through the loop, I want to put the background in the new square. Actually, it doesn't really matter because it's going to build up from the bottom. I could do a new square every time, but I don't really have to. So let me see what we're going to do. Let's just go into a loop, and right away I'm going to do an end loop, and I'm going to make my background. I'm going to put it to a background I indent, very important, of course, and I'm going to do draw.fill box from 0, 0 to max x, max y, and let's do it black. And actually, I'm going to move it out for now. It shouldn't make a difference. Maybe we could try it at the end just to see if it makes a difference. But because I'm just drawing from a smaller box that's going up to a bigger box, then I really want to I don't only have to draw the background once. However, if we go the opposite way, maybe I'll try that second, then it should make a difference. But let's go in here. So there's my background, and then the first thing I'm going to do is I'm going to draw my box. It's going to be at 0, 0. It's going to go to corner, corner, and I'm going to make it red. So it starts at 1. I'm going to draw a box from 0, 0 to 1, 1. Then I got to get it to go to 2, right? So I've got to get it to add 1. There we go. It's going to add 1 to it. And there's my body. Do I need anything else in my body? Let's put a little delay. Not long. Just so it pauses. And then I need my exit. Exit when what? Corner equals, let's go greater than, because we know it's got to get past that. Now my screen is shorter than it is wide, so I'm going to go until it gets to max y, and then it should stop. Just switching it to full screen, so hopefully we can see the whole thing run, and hopefully it works. Here goes. Let's see. There it goes, building up nicely. Looks like it is. All the way up. Hopefully it stops up here and doesn't keep running. And there we go. Nice. Very nice. Okay, I was also talking about maybe going the opposite direction. So let's start with a big red box. Instead of it growing up this way, let's start with a big red box. Let's start it up in the top corner. And how could we get it to go back and down to a small box in here? So we'll start at full screen, and then it'll come back down, and we'll lose the box. So the first thing I'm going to do is I want that background to show up every time, because what I'm going to do is when I graph it, when I draw it, it's going to it's like putting a black page over top of the screen, so it wipes everything out, and then I draw my new box, and hopefully it's going to see it come down. So we're going to start corner up in the top corner, which is, let's go with max X, so it's all the way over. Now we're going to go max X and max Y. No, let's just call it max Y, because that's a smaller number. I think it'll work better. Now, instead of here corner and quarter, because I'm going to subtract the value of corner. Actually, I'm going to start it at 1. Watch this. This is it. I got it now. See, sometimes you don't know what you're going to do until you actually start thinking about it. So I'm going to start it at max X, max Y. This red box. But each time through, I'm going to subtract counter. And then counter is going to still increase it by 1. So everything's still increasing. It's exactly the same thing, except for I've moved the black fill box inside. So every time I'm going to wipe out my screen, and then every time I'm going to draw my new red box. But I'm subtracting counter, and this won't work as I think about it. I'm going to actually put it at, because I want it to always be up in that top corner. So my initial box is going to be at max X, max Y, not 0, 0. I want it to go the other way. So it's going to start up here, and then I'm going to subtract 1. So if you think about it, let's say max X, max Y were both 1,000. I'm now going to be drawing from 1,000, 1,000 to 999, 999. And the next time 1,000, 1,000 to 998, 998, and so on, and all the way down. Let's hope this works, and it should still stop at max Y. Alright, cross your fingers. Here it goes. Oh, error. Why did it get an error? Oh, counter. Who put counter here? Should be corner. Got confused with my other programs. Corner. Yeah, let's run this now. Oh, here it comes. Well, we get a bit of flicker now. Reason why we're getting that flicker is because we're putting that black screen over top every time. But let's just see if it stops at the right time. Oh, yep, there it is. It stopped. Perfect. So let's get rid of the flicker. Some of you may have seen this already, but some of you may not have. I'm going to put off-screen only in there. So off-screen only means I'm building up the screens each time on a separate screen off. You can think of it in memory, but think of it as if it was building up on your neighbor's computer screen. So in order to do an off-screen only, though, nothing shows up on the screen. See, if I run it, I mean, I get nothing. It looks like it's not working. I'm just going to let it run, though. Eventually, it should stop. It'll stop with my final picture, which will be that red box. There it is. Okay? Still took the same amount of time, but because it's off-screen only, it's doing it all off-screen. Now, to get it to update the screen more often, I need to do a view.update. So I'm going to do it before the delay, a view.update. So view.update takes that off-screen only and throws it on the screen so we can see it every time. And now hopefully the flicker's gone. See? Much smoother. I'm not overlaying with the black at the same time. I'm in fact overlaying with the black, putting the red on all in the same instance, and then throwing it on the screen. It's not going on separately. And look how smooth that looks now. Anyways, that's good. I hope that gave you some ideas on how to do some of the things. If you're finished all 7 of these questions, you should now go on and work on the second handout, the exercise question numbers, or exercise sheet number 2. And they're a little bit more involved, the questions, and hopefully you're successful on them. All right, thanks.